for modeling. So now we feel that the data is ready. So how do we know that the data is ready for modeling? Let me see if this was exactly the notebook we used. I think so, for what I'm seeing. Let me just go down. How do we know that the data is perfect? Are you sure this is the data? Yeah, this is data, right? Yeah, this is data. So how are we sure that the data is ready for modeling? So this is what we should be focusing on now. How are we sure that the data is ready for modeling? Because it has no identifier. There is no identifier, number one. Number two, all the numbers are what? Numeric, right? Remember that has been what we have been trying to rectify to make sure that we don't have missing value and to also ensure that all the values are numeric. And then we have also generated more features. And then we have also learned how to select features, because I could remember that this was not the entire data set. This is just the selection of 3 headers from the data set. Okay, so now, so I just wanted us to know that as data scientists, when you are given data, there might be need for you to prepare it. And what we have been doing for the past, if not 2 months, is data preparation, right? Data prep, data preparation, trying to perfect the data for modeling. Now we are entering modeling. So this topic, anything from this topic down is data what? Modeling, no longer preparation. So you don't bring in clustering when you have not what? Perfected the data. Because once you start clustering your data, it means you are already modeling. So let's quickly look at, let me preview it in a bigger view so that we can see it. Okay, so let's start with what is the objective of this particular section where we are looking at clustering. In this section, we will introduce fundamentals of clustering and compare in this section, we will introduce fundamentals of clustering and compare 3 popular clustering techniques. And what are these 3 popular clustering techniques that every data scientist must know? We have the K-mean clustering, we have the hierarchical clustering, and then we have a DB scan clustering. So that's going to be our focus. So like I've highlighted here, our goal for this section is for us to learn how clustering model fundamentally work. We are also going to learn how to use Python to apply different clustering models and interpret their results. That is the key. At the end of your modeling, you must be able to interpret the results in a non-technical format. Then we are also going to compare and contrast the 3 of them. So at the end of the day, we'll know which one we feel is better for us. So let's start with the clustering basics. Now, what is the main, how do we define clustering, or what is the clustering concept all about? Clustering allows you to find concentration or groups of observations which are similar to one another but distinct from other groups. So the diagram, the picture on the screen has explained it. So you can see that these are like throwing different values in one model. And then you now cluster. The word cluster, if you want to break it down, it means what? Grouping. Are you with me? Grouping. That is, you have a data set like sales inventory. Let me just relate it to a live scenario, because this is a bit logical if you don't really picture it very well. Now, you have customers collected, that's customer transaction, or let's say you have your sales transaction, and you want to cluster your customers. So you are going to ask yourself, what factor will you use to what? To cluster them. In other words, you want to group your customers. You want to categorize your customer. What factor will you use to classify them? Is either we use their purchase behavior, right, to cluster them. That is, we look at the one that purchase, the regular customer. We can put them in one word, cluster. Then we can measure it like that until we are able to have. So what I have on the screen now is how many cluster? 3 cluster. So you can have 2 cluster, you can have 4, you can have 5. But mind you, the more cluster you have, the more difficult it becomes to interpret. So it's not just about clustering, it's about what? Interpretation. You are going to see how we go.
Can you say that clustering is in the interpretation?
Yes, every of them. What we are doing is that we are trying to, this is still concept derived from data analytics. So which means that you are looking for something. So at the end of the day, you are clustering them so that you can easily see what you are looking for. So you must put it in word that after clustering, this is what you discover. So that discovery that you are noting is called the clustered word interpretation. And it is that interpretation that will be used for the decision. Can I proceed? Now, let's look at the workflow, clustering workflow. Now, look at it. Here, I'm trying to picture the way we are going to flow with this. So you can see the reason why, which one comes first? Under what? The general clustering workflow consists of the following. Which one comes first? Have we done that one? Yes. So you cannot talk about clustering when you have not prepared your data. Now, where we are now is what? Modeling, right? Where we are now is modeling. That is where, so we just have to know that the workflow or the procedures for clustering your data involve these stages. It starts from preparing your data so that you can remove all the identifiers and also make sure that you don't have missing values in your data before that data is perfected to be modeled. So at this point now, you have started analysis, but it is not, this is categorical analysis, grouping, segmenting, because that is what unsupervised machine learning focus on. So just to brief what we are expected to do under each of these stages, under data preparation, we have, that is where you get your data ready to be imputed into a machine learning model. So in case you are asked, why do we prepare data in the field of data science? Is because the data, so that the data can be fit to be put into a model. Then what are the things you did? What are the operations? So here I want to assume that probably maybe you must have forgotten some of the things we did, but here I'm recapping some of them. Under data preparation, you will agree with me that we have done what? Single table, null and numeric data. Then we have also done what? Feature engineering, selection, and scaling. So all of this falls under data preparation. Now, under data modeling, what do we have there? Apply a clustering algorithm. what are the methods or the techniques that are under data modeling? We have the K-mean clustering, we have the hierarchical clustering, and then we have the DB scan, like I've mentioned before. So for now, everything we are learning now, even if you don't write the that tuning and selection, there might not be issue because everything I want to teach us in this section, zero in what? Modeling. But just make sure that you write the concept under modeling. So just to add to it, there's a reminder that I put there that there is no right answer. So I'm using it to also inform us that you are actually expected to use your intuition in most cases, because you cannot say that this is the most perfect method. So I said there is no right answer or single optimization metric when it comes to clustering. The best outputs are the ones which helps you answer the question at hand. That is the emphasis. And make practical, data-driven business decisions. So you might come across another person showing you different concepts. That is how the person feels he can address the task before him. But at least we have conventional standard. Can I proceed?
Yes.
Okay. Now let's look at what is K-mean clustering. Remember, out of the three, we are starting with K-mean clustering. So K-mean clustering is a popular algorithm. So in case you are asked as a data scientist, what are the algorithms you use in building your model? So K-mean clustering is one of the algorithm. I said it's a popular algorithm which assign each observation in a data set to a specific cluster, where letter K represent the numbers of clusters, like that diagram that I showed you before. So in that first picture, the number of K will be what? 3. So the K represents the numbers of clusters. So let's look at the K-mean clustering. We are still on it. I think here I'm trying to explain how it works. Beyond that definition, here is how it works. So the first one is select K, arbitrary location in a scatter plot. So here we are going to work with more advanced graphs instead of just a bar and a pie chart. Because when you are interpreting your model in data science, most time we use scatter plots and box plots than all those bar plots and the rest. Arbitrary location in a scatter plot as a cluster centers. So the word center, in most cases, we can as well refer to it as centroid. So anytime I use the word centroid or center, they mean the same thing. And assign each observation to cluster based on the closest centroid. So we are going to group this value based on how close they are. That is why I was saying the other time when I was using the business sales inventory. How do you cluster your customer? You are going to use their purchasing behavior. So someone else can say, okay, maybe the values where you have some, for example, now you have profits 5,000, you have profits 6,000, you have profits 1,000, you have profits 500. So all the ones that generate profit within 500 will be in one cluster. The one that generate profit within 1,000 will be in another cluster. That case, you are using what factor do you think we are using for the clustering? In that case, we are using the amount, right? We are using the amount. So you have to decide the factor you want to use. But in this context, we are using how close and how distant one value is to another. Then number 2, we are going to be recalculating and relocating each central to the mean, that is the average now, to the mean of the observation assigned to it. Then reassign each observation to its new closest central. Look up. Let me just go back a little to that first diagram so that you understand it. Look at this. You can see that what? This is not the final word clustering, because some of these are still far from each other. So you recalculate until you get the closest that the next time you recalculate is not changing. That is where you know that what? You have come to the end of what? That cluster. So that is what we are trying to highlight here. So we are going to be recalculating. So sometime when you are clustering, the first calculation will not give you the what? The cluster, until you redo it again. Then number 3, we are going to be repeating the process until observation no longer what? Change. So all this, we are going to practicalize all of this with Python Advanced Library, but I just want us to have the basic first. So here, I think it's the same thing. Did I capture use case? I didn't capture. Here, I'm capturing what? Use case. So what we have to copy here now is just what? Example of what? Use case. So we want to look at, we want to conceptualize in real life scenario, how am I going to apply what? This clustering concept. I say identifying customer segment for targeted marketing campaigns. So for example, a company wants to deploy their digital marketer. And in digital marketing, we have to call what? Target what? Audience. You don't just place products in front of anybody or everybody. We take our time to identify our niche and what? The location of the targeted what? Audience. So a company that wants to run ad, we use the results, your interpretation at the end of the day. We guide them in launching what? Or advertising, because your clustering will have given them an idea of the direction they should go. So the second one is clustering stock location based on factors like sales, rating, size. Do we understand that statement, the last one? Can anybody interpret that last one? Let me know if you understand what I mean by that. Clustering store location based on the factors like sales, rating, size. Let's say you have shops now. You want to cluster them. You know, you can have business, you can have like branches all over the country. And you want to cluster them, you want to group them. So you can group them based on the sales strength, right? You can also group them based on the rating, how these branches have been rated by customer. You can also group them by the size, how big they are. So this, we are trying to picture some real life application of what we are learning. Now let's look at the step 2. Assign each observation to what? Cluster based on the what? The closest what? Central. You can see that at this level now, can we say that they are actually properly clustered? What do you notice? Good, they are far away from each other. So let's quickly write this step because I want to move to the next step, step 3. What was step 1? Good. Then step 2 is what? No, this is it. Step 1 is the other one, that slide. Okay. Yes. Yeah, the whole of that is in step 1. Now, step 2 is assign each observation to a cluster based on the closest centroid. Can we move? So step 2. Relocate each centroid. So the practical step we are going to do is what I'm trying to highlight now, so that you know that as we are going, this is what we are achieving. Relocate each centroid to the mean of its assigned observation. So we are going to calculate the average of each of the values centroid under each of the column in the selected data we are working with. Relocate each centroid to the mean of its assigned observations and reassign each observation to the new closest centroid. So that is going to be our step 3. So I want us to look at the differences between the pictures as we are advancing with the steps. Are the pictures still remain the same? So what do you observe? We are trying to make sure that what all these ones find their way, right? We are trying to bring them closer. So all these ones, this is the central. This, you are not seeing it. You are not seeing my mouse here. That, sorry, the way I projected that that arrow from that big cycle, that arrow point to the other big cycle, that is to indicate that what? That one is just like a magneto that is magneting them. Right? To say that what you are bringing them what? Closer. And this other one for this side, where you have the bigger cycles. That one too is trying to what? To drag the yellow color. So at the end of the day now, you end up what? Having them what? Properly what? Clustered. So the closest, that is what we are talking about. So the distance is what is using. Now, step 4. What is the difference between this one and the previous one? Can you see that what those other ones that were on this side, they have finally what? Located their location now. Now, step 4 is continue to relocate. That's why we highlighted then for that word you repeat until you get to the word to the closest before you stop clustering. Continue to relocate each centroid to the mean of its assigned observation until the cluster no longer change. Can I move? Yeah. Now, this is in Python now. We are coming to Python now. This is the code, but I want to explain it here. So the whole of this grammar that we are blowing now, this line is what is doing the clustering. Now, like I said here, K-mean clustering in Python now. So we are done with the science, the theory part now. You can use, which library are we highlighting here? Which library carries all the functions that will be used for the clustering? K-mean what? Sorry, sklearn what? K-means function is a library. I think we use this sklearn the other time too, right? Sklearn K-mean function to perform what? K-mean clustering. Remember I said we have three what? Three methods for modeling, right? One is what? K-mean clustering. The other one is what? Hierarchical. And the last one is what? DB scan. So everything we are learning now, we are still on that word, the K-mean clustering. Now, from this is where you are importing the first line. The first line is where you are importing the library that houses the average function. Because we are calculating the average of each set of value what? Central. To measure whether they are to what? To be clustered in one group or the other. Now, just like I've labeled here, this is an object. So the K-means before the equal sign is what? A variable, is an object that we are storing the function into. So the K-mean and the brackets, remember after the K-mean, I think I need to Let me switch to my PowerPoint so that I can be pointing to what I'm saying for better understanding. Okay, good. Now, this particular section here is a function which you have imported through what? The sklearn what? Library. Now, the function need parameter to work with. The parameter means what? Set of data to work with. The first parameter we are giving is the number of what? Cluster. So this n underscore what? Clusters is an attribute that defines how many group do you want. So we are going to progress from 2 group to what? 3 cluster, 4 cluster. But that is how you learn. You start from 2 cluster because your data set is already in what? 1 cluster. So there's no point of you doing what? 1 cluster. You start from 2. Now, this n underscore init auto, the number of model to fit with different initial central. So that init means what? Initial what? Central. That's the center. And we are programming it on auto. The reason why we are programming it on auto is that so that the value does not change periodically. Because if you leave it blank, most of them are optional. If you run this code without defining this, it will work. But the only thing is that what? Anytime you run the code, the clustered will be changing value. Now we have the random underscore states 42 as a value, which means setting a random state value guarantees the same result each time the model is fit. That fit means transformation. Each time you run it, it means you are transforming. So if you don't add it, that means that what? It will keep generating different results each time you deploy the model. So professional advice. It is typically a good idea to start with what? 2 cluster. You can read it if you cannot see very well what I'm reading it now. It is typically a good idea to start with 2 clusters and build up from there, like I had advised before. Always start from 2, and then you can build up from there. Are we together? Guys, go back. Okay. Maybe I should close it back. We'll still go to Python. Let me just finish. Better now. All right. Now, here, there is a concept I want to explain here. I want us to pay attention to the way the values are reacting here. Example, we are saying clustering high school students based on entertainment preference. So the local library, this is what I try to cite a live scenario. A local library can use targeted ads to encourage what? Teenagers to read more. So this is just like a library trying to woo students to read what? To read more. And they want to run ads. Then you as a data scientist, based on the previous data, they want to know how to go about it. Now here, of course, you know some of this already. This is where we are selecting the first word, 10, just to view. Then if you look at the key note here, I said some students spend almost what? No time reading what? Each week. Students prefer to spend what? Most of their time playing video games. These are reality, even in today's world now. Okay. Now we are going somewhere. We are trying to get a picture of where we are going. So now here, this is the whole code. The whole code, this is the first code we are going to run now on that same data. I believe we have this data now. Okay, don't worry, I'll give it to us. Now in Python, here we are in here, k-mean clustering in Python. So here I'm trying to explain the code first. Import k-mean from what? sklearn. From sklearn dot what? Cluster, import what? K-means. So this k-mean is what? The function that we calculate the average, because it is the average we are using to locate what? The central or the center. Now fit a k-mean model with two what? Cluster. How do I know that it's two cluster? Look at it here, right? I've explained it before. Now, here, once you run this code, this is the result you're going to get. This result will have calculated what? The center, that is the mean of each value under what? This data that, so we are focusing on the column. Now, so let's go to Python together now. So what I'm going to do now is to import pandas library and read in what? Entertain clean. There is a data set that has been cleaned. So if you don't have it, I think I have to start by giving it to us. You have it. The one that have, okay, I've given us that folder called database. Good. So that is what we are working with. You are calling it, you are opening another notebook. Yes, another notebook entirely. Yes, please, another notebook. Don't continue with that one.
Under this.
Yes, under that same folder. Good. Another notebook. Then we'll call in that data. So let me quickly go and do the same thing as well. Let me go back to home. I'll create a new notebook. So I'll name it that data modeling. Let me name it data modeling. Yes. Okay, so the first thing is that let's read in our library. So let's use comments. Import Panda, because we want to read what? External data. We are not creating the data, so we have to import our data reading library. Import pandas as PD. As PD.
Speedy, so import pandas as speedy. Then bd dot read underscore CSV. Then let me quickly go and call the data part. I hope I have it here. Good. Is it? Copy the parts. Go back to my model, then paste as usual. Then let me use relative method. Okay. We're on the same page, right? Mr. Mo, are you there? You are here to get your data in. Okay, let's wait for you.
Let's quickly go to the next. So now you can see that the data you outputted does not have a name. It's not saved in an object yet. Are you with me?
Yeah.
We have not saved this data. This is just, so let's say that's the next step now. Let's save it. Let's quickly save it as now save the data. As df object, which means data frame, can be any name. So what I will simply do is to say df equals to, and then copy the whole of this line. Control C, then paste it here, then run it. Then to see my value as usual, I'll do my df. Once we are on the same page, let me know so that I can just move on. We are right? Okay. So the next step is what? Now, look at it. Before you start your modeling, there are 3 steps. There are 6 good steps. Or let me not call them steps. Let me call them assessments. And you have to be asking yourself the question whether you have actually what done that before embarking on clustering. And what are the steps? Role what? Granularity. Column what? None what? None. Columns numeric. Feature engineering. Feature selection. Feature what? Scaling. So which means that all these data preparation steps must have been duly what? Observed before embarking on this. So here, but you will not assume that the data, remember that we are not the one that clean this data. It's not the one we clean, right? So let's assume that someone else in another department, someone else have already cleaned it for you and give it to you. Before you continue as a data scientist modeling it, you have to check. So one of the ways we're going to check is by writing what? Let's find out, let's check the width and the height of the data. Let's even know how many records and how many columns are in the data set in quotes. Then we'll also find out how many unique. This is another method that probably we have not used before. How many unique? So this one is to check the total unique rows. Who can tell us what that result will inform you? If you check total unique row, you are trying to check whether there is what? Good. Remember that when we are learning row granularity, what we're ensuring is that each customer represents what? One row. We don't want to whereby prosper will be repeated what? In multiple rows. So once you run this function and it shows you the same 150, it shows that what? No single customer is repeated what? Twice. So you are sure that what? Your row are in the right what? Granularity. So now let me quickly go there and check mine as well. So using comments here, the first thing is to check the width. Let's start by checking the width of the DF. And that is DF dot shape 150. Now, let's also check if okay, let's check total unique rows. So the syntax will be df dot, you know, the column that we are focusing on, the column we want you to check. Look at this. We are focusing on what? Name column. So you say name. We know all this method of data selection. All these one are their skills we learn under what? Data selection. Then dot unique good. So I have what? 150. So even as we run this now, we are having like 151 or 160. That is what you go back to your data what? Preparation before you can continue with this process. Now, let's do something. Let's check. Remember that we are observing those 6 steps that I said you need to clarify before you start your modeling. Now, let's check for what? Missing value. And to check for missing value, we simply do what? The data set dot what is NA. So let me quickly go there. Now, check for missing values, which is what? DF dot is now. Okay. Now, remember that there is a challenge that we usually have where the data is much, right? If you are using just what? Is now. So because of that, we will add what? We will add this. Just remember this. Because that one that we run cannot actually be used to confirm. Because there are some, because the data is much. So there are some in between that you are not seeing. So the best thing is for you to run what? Is now with what? Dot any, so that it will call out only rows where you have missing value. So by the time you run it, if you display any record outside what? The heading, it means that what? There are missing value. But for it to output like this, it means that what? No missing value. So let's quickly run that to confirm. So now let's check using comments. Now call only rows with missing values. So the syntax will be df, which is your data set, that is from the data set, because you are selecting some, you are not referring to everything. So from the entire data set, you are selecting the df dot specify the add the function any. So while you are still inside the square bracket, if I run this one only, remember that I will get a value. So this is what I will get. I won't get actual value. So I will now add dot what any dot any. I remember because you are selecting across the row, you have to add what as is equals to 1. Then if I run this, so this output nothing, which shows that there is no what? What does this confirm? There is no row where we have what? Missing value. If we have, it will have listed it. Are we together? Okay, now let's go to the next one. Now to check if columns are all numbers, remember, it's part of those 6 things we highlighted before we start clustering. Because if all these are not well done, that is where you have issue. That particular k-mean and order will not work if the data is not in the right format. So here, let's check the data type. Remember that you just run what? df, the name of your data set, dot what? D type. That will output all the headers in your data and also define the type of data that are stored in them. So using comments, check data type. So I will just say df dot d type. Now, if you look at this now, we have name as what? Object. After all, we are going to delete that name, but we know that. We are going to drop the name because it's an identifier. So if you take off that is why I don't want to bother myself making it what? Number. But at least the ones that I need, they are already in what? In proper, they are already in number because this floats. Just that with decimal number. That is why they are not called what? Integer. So they are numbers. Good. So that means that we just confirm that what? All numbers are what? All value are what? Numeric. That is what we just confirmed. So now, we are not attending to feature engineering. We might do that later if the case arises. So out of those 6 steps, I have skipped this one now. Now, here, let's call back the data again because there are some observations I want us to take here. If you call back the data, what I want us to see is this. We can see that there are what? Names, which are called what? Identifier, which cannot be passed into what? Model. So there will be a need for us to do what? Drop this column. So at the end of the day, our clustering model we have only what? Books, TV show, and video what? Underscore game. So if we go back there now to call back the data again by just calling let's call only the first, let's say df, let me use that. To view data again, just do df dot head. How many did I specify there? Or just dot head? Okay, dot head. So here we observe, like I said, observation. Observe that the data frame or set still have identifier. identifiers which cannot be passed into model. So based on that, we have to do what? Drop it. We have to drop it, and this is the code for dropping it. So all these ones, they are still part of revision, part of what we have done before. So therefore, drop the name column with I am dropping at the same time, I am resaving it. Okay? Because once I drop it now, it will no longer be the same as what? DF. So I'm quickly changing the name to what? Data equals to. So data is what I'm going to work with as the perfect data for the model. So equals to df dot the drop function. Then we have to define the column we want to drop using the column attribute. And then the name of that is a string, so we have to quote it. And then, of course, I will just view the first 5 by using .head, just to confirm if I've actually what? Drop it. Good. So the column is dropped. All right. Now, so the next step is what? We want to describe it. Now, the reason why I want to describe, I want to make sure that what? We have, remember the last topic. What was the last topic? I think we did something like scaling. Good. We did scaling, right? Where we ensure that what? Our values are within what? Workable range. 0 and good, using that standardization. Or what? Normalization, right? Good. So now we want to know. That is what we are checking here now. Let me go back. Was it here? Okay, here. Sorry. Okay, so we are also leaving this for now, but let's just do the describe. The reason why I'm going to leave it is this. So if I do data describe data objects, just to know the scaling or the scaling what? Range. So I'll simply do data dot describe. Data dot describe. Now remember the factor then when we were scaling was the minimum and what? The maximum, right? The minimum I have here is within what? 0. And the maximum I have here is what? For this column, you can see that what the range is okay, it's workable. Look at it, the difference is not much. 6.6, 7 point. That is why I don't want to, I can go with it. RDB, here is 6 points. Here is like 15 points. You'll be forced to go and do scaling. Because the differences are much, you understand? But when you look at that, like, okay, they are very close, you can work with it. Good. So that is the reason why I said we are leaving what? This one for now. Now, this is just like you calling it again. just for modeling. So I will just move to this. So this is where we will now start running. So here we have started what? Clustering. Using which technique? K-mean clustering. So let's quickly write this. So we are writing this with the assumption that we have cleared the data from those systems. We have the correct what? Row granularity. We have the right features. There's no need for engineering new ones. We have selected the right data. There is no need for selection. And then we have also checked the range between the minimum and the maximum in each of the column. And we discover that what? They are okay to go with. Now we want to cluster. So the first thing I'm going to do, comment. So let's say what? Data clustering using K-mean. Please, it's case sensitive. Where you see capital letter, you observe it. Using K-mean clustering. Technique. So I said you start by importing, say from sklen dot cluster imports. Import K-mean. The K is capital letter and the M is capital letter. So if I run this just to confirm first before I execute the next code. Yes, the K and N, capital letter. So let's confirm that line first before we proceed with the code. Good, confirms, which means that what? The library and each sub functions are successfully imported. So the next thing I want to do is I want to store so now I need to determine my cluster now. To the next line, which is this. So the next line is K-mean. K-mean, we are following the same cases. Function. Then N underscore clusters equals to, how many of them do I want? 2, comma, N underscore inits auto. So I need to make this a string. Comma, random yeah, that 42 is just my constant, like I said, to avoid it changing each time you execute it. random states equals to 42. Okay. So that has automatically calculated the mean. Remember, when I was giving us the note, I said what? The centroid will be calculated based on what? The average, which is the mean. So that is what this has done. Now, if I go back to my slide now, so now for us to confirm, this is for us to confirm. Let me see. It's like I omitted something. Okay, I did not store it in an object, so I have to store this in an object. Please, let's write this code like this. I have to store it in an object. So this is an object. K means 2 is an object like your own variable. And then we are storing the whole of that code inside. Then we'll now use the object to transform the data so that it can work on your data directly. Because that one is as if you did not pass in any data to transform or to model. Have you written? Can I move? This is only what we are adding. We just add equals to that one, then we use it. Okay. That's where I get it here. So here, at this point here, what we want to do here is storing the k-mean. The k-mean results in an object. So I will say k-mean, this one is just my object. It can be lowercase, k-mean 2. So equals to the whole of this code that we have confirmed. Paste it, and then initialize it. Then you will now use your object, which is this km to transform the data. So that fit means transform is a sub function under the k-mean library that you imported. Then you are supplying the data is going to transform, which is what? Data, the name of your data. So to now calculate the average, of the values inside each of those columns in the data you supply. That is what will happen. Now, if we now want to check, whether the average has been calculated. You now use the object and then put dot, then use tab. These are other manipulative functions. Let me see if I can reduce it so that we can see everything in the slide. So type the model name and period to display order operation with the model. To display order operation with the model. That's what I want to say here. Now, see what I want to do here. Now, we want to confirm if truly the average of each value under each of those columns have been calculated as the basis or factor for the clustering. So I have already stored the whole of that function in the k-mean. So what I'm going to do is this. So I will just come here and say here to check if the average or mean of each values in the data column has been calculated. Remember, that is going to be the criteria for the cluster. So I will simply type the object name, which is the k-mean 2. Then once you put dots, try your own whether it will pop up. Once you type it and put dots, supposed to pop up those information. Check your own. Though what I was looking for, if I know it, which is what? Label. So this is what I want to use. So I want to use this particular property to check label. So since it's not bringing it out, I can manually add it. That is labels underscore. Labels underscore. So I will just say what? Label dot label underscore. So if I run it, good. So now you can see the clustering. How many clustering do we specify? 2, right? What is the clustering here? Some are 0, some are what? 1. So this is the result we got there now. So which means that if, for example, now you change this place, I want to try that, change this place to what? To 3. And run it again. Let me see what you get quickly. Because this is why all the values are clustered into what? 0 and 2. Why? Because we define what? 2 clustered. Good, exactly. Good, exactly. 3 will give you 0 what? 0, no. 3 will give you 0, 1, 0, 1, 2. Yes. Yeah, okay. Yeah. We'll give you 0, 1, 2. Yes. So that is for this. Now, we now want to interpret. Remember, I told you that what? Interpretation of it matters. That is the last thing you must do. Each time you cluster, you are clustering so that you can observe the reaction or the behavior of the data in order for you to write your interpretation. Now, if you want to interpret, so I will just call this particular data back. If I call this data back, based on the values we have under them, the ones that are within, we are focusing on book. We are focusing on the value here to write down our observation. So focusing on book, the first 3 students are in 1 cluster, which is what? 0 cluster. While the last 2 students in another word cluster, which is what? 1 cluster. That is what Python did for you. Which means that these ones here, we are going to give them name at the end of the day, whether they are maybe book lover or people that don't like reading. So that is what we form the report we are going to give at the end of the day. So this is where this particular one stops. Any question? So this is where this particular cluster, so we have been able to cluster the whole of those values into 0 and 1, which is just what? 2 clusters. So like I said, try that 1 or 3. Let's see. Try the same method for. Let's look at the visualization. That's visualizing that particular cluster now. Visualizing the k-mean cluster. That's the next. So this is expected to be the outcome, but we have to explain the code. This is visualization code you will write for you to. So this is giving us a picture of where we started from. You can see that what? These columns that are in one place now will represent what? One of the cluster. While this other one represents what? Another what? Cluster. So until you visualize it, sometimes you may not really know. Though the binary number there, those numbers are actually giving us an idea that what? They are clustered. But if you look at the results now, they are still mixed up. We don't have all the zero in one side. We don't have all the ones in one side. So that is why it is better you visualize it so that because that will give you the real picture of what is happening. So I will preview this in a bigger form, then you will copy it before we start applying it. Let me see. Okay, so you can copy now. Once don't copy, then we can proceed. Let me just. Now I have look up because this code could be much. Actually got the code from Google. There's a place where you can actually get 3D modeling code. Then you just customize it once you know how to substitute the parameters. So just go to Google. We can be doing it together. Once you're on the internet, search for 3D scatter plots within Python. Just go to Google and search for 3D scatter plots within Python. So let me go there now and check. So in case you don't want to go with this very one that I've customized, you can go there and get other 3D plotting codes. Say 3D scatter plots. Scatter plot what? 3D scatter plots within Python. Within Python. So you can see them here. So this is the one. I can click here, you can see it. So they have different code. So let me click on this one. Go to the documentation. There you see the code. It's just for you to substitute. There are a whole lot of them, depending on. So this is where we got those code from. Now, but in my own case, so this is trying to show how. Then click on this one. Now I want to get my code that will not troubleshoot. Let me get my code to see if we are going to get the same results or you can trouble. No, that thing is not equal, so it's asterisk. Now please net is asterisk. So let me just copy and then go to my notebook. The C. So let me see it. The
name C.
The name C. That name C represents color now. Wait, let me see.
In that I thought one to be regular.
Okay, the name came into is not defined. Now it means that the name I use might be different. Let me check where I pass in the data.
Check all those ones. Came into the even came into because that's what we're using.
Yes. So where is it complaining is now? From yeah, I have to change some things here. Is it came into that use? That means it's supposed to be aligned now. Came into Now, have you run the entire sheet again? Let's see whether K means 2 is any different from, let me check my own. Okay, yeah, this one I have in the function, I put S. But this one does not have S, so I need to change it. Where is it now? Let me try and figure my own out. There's no S, but there's came into. There's no S. Try that one again. Any other place where I use it? Good, perfect. So plotted. So let debug. Check here. Maybe cap log.
Oh, this one, I run this one.
Run this one now. From where? What's the code? I'm looking for somewhere to see that.
Now, you see, as we put the code together, like I told us that you can actually go to that particular website or Google to get some of this code. But just for us to know what individuals of those lines actually did. So here I want to explain each of them, the ones that may be a little bit difficult for us to understand. So for example, now if you look at the code, there was a place where you say cluster. Now if you want to check in this particular code, there is the code. In this code, this is the one I want to explain now. So if we run this code alone, what are we saying? So that by the time you put it together, you understand what the whole of this code does. Running this code alone, it means that what? It takes the clustered label and made it what? Into a series and name it what? Name it what? The series what? Cluster. That is what this name did. So let's run just this code. Okay, good. You must have confirmed it as we were taking it before. Good. I mean, you have even helped you as if you know that we are going to. So let me just run through the explanation, but I have not done mine. I have not done mine. So if I have to wait there. Okay, so just to explain the code, just to know what the code does. So let's say we have clustered label. I'm just using the name. equals to, let me see if I have it here to save my time. Okay, this is it now, eh? Okay. So I run it. So let me output the value. So you can see it. Now, the next one I want to explain is this particular line where you have that is the clean one where we concatenated. So here we are joining the result of that one, that series now, plus the actual data now. That is what we are doing here. So which is, I will have to So here, what we are doing here, we are actually concatenating. So the function is concatenating the series and the series data and the main data set. The main data set. So that is TF as the name clean. Yes. So I think I should have it here also. To save my time, this is where we are now, right? I'll take the whole of this, Control C. Run it. Then let me output df underscore clean. Okay, so you can see where is the series here now. This is a cluster, this is what? Say it together, good. So you can see that because sometimes when you copy the whole of those code without confirming like this, it can be difficult to interpret. Now, this particular section, this is where you are defining the size, this big size, the size of, so you can go and try it now, change here to a higher number and see to increase the size of the graph itself. So this is the aspect that controls it. While this one is one that converts it to 3D. I don't need to explain this. So you already know what they do. So you can just change that value from A to a higher number and see if the graph will increase or it will reduce. So you can actually use it to increase any graph, not just this. Even your pie chart, bar chart, you want to increase the size after plotting. Maybe when you have so many values, are compacted, you want to space them. Did it work? Okay. Now here, what are we doing here? Here, I need to explain all this. Look up, I've listed them. Make sure you write them. Here, a lot of interpretation are here. This section that you have in this code represent what? The S what? Axis. While this section represents what? Because this 3D graph represent the y-axis, while here represents what? The s-axis. That C equals to D represent the color that determine the what? The coloring of what? And we have just two colors based on our cluster. Two numbers, 0 and what? 1. That's why we have just two colors. Now, the C map or C mapping, tab 10, represent color mapping that control the actual color. So we can change this value and see how it's going to change the color. This is tab 10, right? And you can put tab 9 and see whether it's going to change the color because that's supposed to control the color. Then here, This is where we define the axis, the information that will be represented across the three axes, both the X, the Y, and the Z. That is what this one does, this very one here, labeling all the words, the axis. Now here, this is where you are interpreting. I told you at the end of everything, you have to interpret. We have to write this note. I don't think you have written this note. So you can interpret the result of K-mean model using the cluster word, centers, attributes, and your intuition. So for example, now you can just do data.column to see the number of headers, then K-mean.work, cluster _ center. So that will now bring only the middle points. The middle points. So I think let me make this one big so that we can see it. How do I? Okay. I'm coming so that you can see all the information here. So if you look at what you have here, view the column name, view the cluster center. So the interpretation of the first cluster is the students in the first cluster spend on average 4.2 hours reading books, 4.3 hours watching TV show, 6.3 hours playing video game. Then the students in the second cluster students in the second cluster spend on average 0.6 hour reading books, 5.1 hour watching TV, 5 hours playing video game. So conclusion, the students consume a good amount of each type of content. So we could name them consumers of all types of entertainment. That is for that particular cluster. Then the second cluster, we can conclude by saying these students do not read many books. So we could name them what? Non-reader. This is actually what we are going to present to the stakeholder. This is not technical interpretation. And this is what will influence their decision.